Hello everyone. Welcome back to Dr. Lou's VCE Physics channel. Today, let's learn together about the 2023 NHT physics. We will focus on questions related to light as a particle. My explanations may need to be revised. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. Convert the electron volt to the joule. The conversion factor is the charge of one electron. We know the mass and wavelength, then, use the equation of de Broglie to calculate the speed step by step. Please note that the units of Planck constant are used as joule, not electron volt. The laser produces monochromatic light. Infrared heat lamps and mercury vapor lamps produce discrete visible light. An incandescent globe produces a continuous spectrum of visible light. An infrared heat lamp will also emit a continuous spectrum but will not include the higher frequencies of visible light. The larger the wavelength, the lower the energy. So, the energy of light with a larger wavelength than 300 nanometers is lower than that of 300 nanometers. If 300 nanometers is just able to release photoelectrons, then increasing the wavelength will not produce any photoelectrons. We know the energy level and are asked the value of X. The energy of the emission spectrum is the gap between two energy levels. We can draw the three lines for 1.9, 1.0, and 1.6 electron volts. From the diagram, we know that X is 8.5. The minimum frequency of light produces the work function. Using Planck's equation, we can calculate this frequency. Here, the unit of Planck constant is electron volt because the work function is electron volt. The key is the red light instead of the original UV. The energy of red light is lower than that of UV because the wavelength of red light is larger than that of UV. The larger the wavelength of light, the lower the energy of light. Furthermore, UV is the threshold frequency to eject photons. So, Sam's idea is unlikely to produce more photoelectrons. We know the momentum of electrons, which is the denominator of de Broglie's equation. Here, the units of momentum are kg/ms, so the units of Planck constant should be joule, not electron volt. Electrons have wave-like properties. Diffraction is a property of waves. Salt crystals have a spacing that produces diffraction patterns with a beam of electrons. Explain the quantized energy levels. Electrons have wave properties. In stable energy levels, the electrons will form standing waves and orbit around the nucleus such that the perimeter of the circumference is the whole number of wavelengths. 5 multiple-choice questions are awarded 5 marks, and 3 short-answer questions worth 12 marks in light as a particle. The overall score for this section is 17 points. With a total possible score of 130 points, the percentage for this section is 13.1% of the total score. If you need my help, please add me on WeChat or WhatsApp, and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Physics channel and Lou's VCE Chemistry channel.